Good morning, children. I welcome you to these virtual classes. We know that mathematics is the most beautiful and most powerful creation of the human spirit, without which there is nothing to do. We use math knowledge uh, when we cook, in the process of cooking, because you know that for every recipe there will be ingredients, right? And those ingredients have to be put in the correct proportion. Use the ratio and proportion there, and use the concept of double or half. So if you take 1 cup of one thing, that is say rice flour or whatever it is, and you need to take double the quantity of rice flour, that is water. Okay, like that you will use mathematics in our routine life, right? So let us start our mathematics class. First, to start with, let us glance at the concepts what you have learned in 7th standard. Okay, under algebra. So you had 3 units actually: algebraic expressions, exponents and parts, and simple equations. These 3 you have learnt in algebra. Let us have a glance at those concepts, right? First is algebraic expressions. So you know that you know about variables, constants, right? So variables mean the word variable gives you the meaning which varies. It is an entity which varies, which can take various values. That means its value is not fixed, right? We use English alphabets for denoting the variables. You can use x, y, z, l, m, n, p, q, a, b, c, d, p, q, r, s, whatever you want. And on the other hand, we have the constant which has a fixed value. If you write any number, that becomes a constant. Okay, if we combine the variables and the constants, then we get algebraic expressions. And to get the algebraic expressions, we use the fundamental signs, that is fundamental operations of addition, subtraction, multiplication and division. For example, the expression 4x plus 5 is there, 4x plus 5. So this is obtained from the variable x. We have the variable x here, isn't it? So this is obtained by multiplying x by 4 and adding 5 to 4x, isn't it? So this is an algebraic expression. Then here 4x and 5, these are parts of the algebraic expression, right? So they are said to be the terms of the expression. Parts of an expression which are formed separately first and then added. See 4x, 4, here x we have the variable, right? 4 is a constant. 4x is an algebraic term. 5 is a constant. This is also an algebraic term. So when these are added, these terms are added, we got an expression, algebraic expression. So algebraic terms are added to get the algebraic expressions. Okay, terms are added to form expressions. Now let us consider this example. 4x square minus 3xy. We have two terms here, 4x square and 3xy. Again, that is 4x square and 3 minus 3xy, of course, minus 3xy is there. Thus, this 4x square can be written as the product of 4x and x. So, these are said to be the factors of 4x square. Similarly, minus 3xy can be written as minus 3x and y. So, minus 3x and y are said to be the factors of minus 3xy. Now, let us consider the coefficient of the term. The numerical factor is said to be the numerical coefficient. Here we have 4x square, right? So here the numerical coefficient is 4, right? Or simply the coefficient of the term. Here it is minus 3, right? Sometimes we will say this is a numerical factor or numerical coefficient, and this is literal coefficient. X square is literal coefficient. X square is literal coefficient of this 4. So this is about coefficient of the term. Now let us consider the like and unlike terms. So when the terms have the same algebraic factors, so these like and unlike terms are related to the variables or the algebraic factors. Okay, so if the algebraic factors, if suppose we have two terms, then if the variables present in those two terms are the same, then they are said to be like terms. For example, here 2xy and 5xy. We have the variable xy in both the terms. They are said to be like terms irrespective of their coefficients. They should have the same algebraic factors. So if we go one step ahead, then with the same exponents, the variables should be the same with the same exponents. Okay. Now, you consider another example. Say here 2xy and minus 3x. Here the variables are different. In this we have xy and in this we have only x. That means they are unlike terms. So, like terms will have the same algebraic factors with same exponent, whereas unlike terms have different variables or different exponents. Even though the variables are same with different exponents, then they are said to be unlike terms only. Suppose we have say it is x minus 3x. They are said to be like terms because the variable is the same and the exponent is also same. And unlike terms, say for example 2x 3x square, they are unlike terms. So these are unlike terms because the variable, even though the variable is same, their exponents are different. Similarly, minus 8p then 8q, they are said to be unlike terms because the variables are different. Okay, thus the terms with same algebraic factors with same exponents are said to be like terms, and the terms with same variable different exponents are same exponent different variables, they are said to be unlike terms. I hope it is clear. Then coming to the number of terms in the algebraic expressions. So if an algebraic expression has only one term, that is said to be a monomial. For example, 7xy minus 5m 3z square. I think this is square. 5z square. 4, etc. They are monomials. Now don't get confused with 7xy as binomial. No, a binomial or trinomial should have either plus or minus sign in between. Here we have the multiplication. Multiplication of two terms is the same term only. Okay, it is considered as a single term. So these are the examples for monomials. Similarly, an expression which has two terms which are separated by the either plus or minus sign are said to be binomials. Even this is a square and this is b square. A square minus b square are binomials. Okay, here also mn is a single term. So mn plus 4m is a binomial. Then an expression which contains three terms is called a trinomial, which are again separated by either plus or minus sign. So this is x square minus 5x plus 2, m plus n plus 10. These are trinomials. The expression ab plus a plus b plus 5. Okay. AB plus A plus B plus 5 is, however, not a trinomial because it has 1, 2, 3, 4 terms. It's not a trinomial. It contains 4 terms and not 3. The expression y plus y plus 5x is not a trinomial as the terms x and 5x are like terms. Here you can add x and 5x and you can write this as 6x plus y. It is not a trinomial. In general, an expression with one or more terms is called a polynomial. So, thus a polynomial, a monomial, a binomial and a trinomial are all polynomials. That means you will have the other definition for a polynomial. Okay. Now, I think you will learn about the definition of extended definition of polynomials in this year, that is 8th standard portion. So till 7th standard you have learned that an expression with one or more terms is called a polynomial. Okay. Now following simple steps will help you to decide whether the given terms are like or unlike terms. Ignore the numerical coefficients, concentrate on algebraic part. So as I have already told, like and unlike terms are related to the algebraic factors or algebraic part of the terms, irrespective of the coefficients. You need to ignore the numerical coefficients. Check the variables in the terms, they must be the same. They should have the same variables. Next, check the powers of each variable in terms. They must be the same. That's what I told. The variables with same exponents are said to be like terms. The same variables, same exponents. Okay. So, if the variables are same and exponents are different, then they come under unlike terms. And if the variables are different, then they will also be considered as unlike terms. Note that in deciding like terms, two things do not matter. One is the numerical coefficients of the terms and the order in which the variables are multiplied in the terms. Okay. Now let us consider addition and subtraction. This is extra, children. Please ignore this. Addition and subtraction of algebraic expressions. The sum of two or more like terms is a like term with a numerical coefficient equal to the sum of the numerical coefficients of all the like terms. I will give one example. Suppose we have 3x plus 5x plus 10x. So we are adding these are like terms. We are adding the like terms. So what do? We add their coefficient. We add the coefficients of all the terms, that is 3 plus 5 plus 10x. That comes out to be 18x. So the sum of two or more like terms is a like term. This is also a like term with a numerical coefficient equal to the sum of the numerical coefficients of all the like terms. That's what I have done. I hope it is clear, children. Similarly, the difference between two like terms is a like term with a numerical coefficient equal to the difference between the numerical coefficients of the two like terms. Suppose you have, say, 20 PQ minus 2 PQ. These two are like terms, isn't it? So what is the difference of these two? You need to find the difference of their coefficients. Again you will get a like term, that is 18 PQ. Note, unlike terms cannot be added or subtracted the way in which the like terms are added or subtracted. Suppose you have x plus, say, 2x plus 3y. Then you cannot add these two. They are unlike terms. You cannot write it as 5xy. You cannot write. Okay. Similarly, 5x minus y. You cannot do this. You cannot. Okay, you cannot write it as 4x or 4y or 4xy. 4xy. You cannot do like this. Unlike terms can never be added or subtracted. Now, let us do a note is there. Subtracting a term is same as adding its reverse. Subtracting minus 10b is same as adding 10b minus 10b. Okay. Now, let us add these two. 3x plus 11, 7x minus 5. So let us add. So while adding, you have to just add them. You are adding like terms. So you have to add the coefficients. 3 plus 7 is 10x. And when you are adding a positive and a negative integer, you need to find the difference of those two numbers. Their difference is 6. Then you have to put the sign of the larger factor, larger number. It is plus 6. 10x plus 6. Okay, so this is the sum what we have got when we added 3x plus 11 and 7x minus 5. Now let us subtract a minus b from 3a minus b plus 4. We have 3a minus b plus 4. Now we need to subtract a minus b. So what you should do is, while subtracting, you have to change the sign of the subtrahend. So 3a minus a, isn't it? So this is subtrahend. A minus b is a subtrahend. So you have to change the sign. 3a minus a is 2a, and minus b plus b will get cancelled. You will be left with 0 plus 4. So it is 2a plus 4. Is it clear, children? Then finding the value of an expression. We know that the value of an algebraic expression depends on the values of the variables forming the expression. There are a number of situations in which we need to find the value of an expression, such as when we wish to check whether a particular value of a variable satisfies a given value or not. Here, the value of a is given as 2 and b is given as minus 2. We have to find the value of a square plus b square. In place of a, you need to substitute a. It is 2 square plus b is minus 2 whole square. Now 2 square is 4 plus, don't multiply these two, children. Okay, you have to find negative integer raised to an even power is always positive. So it is plus 4 only. Therefore, it is 8. Here a square is 2 square plus ab is plus 2 into minus 2 plus b is minus 2 whole square. 2 square is 4 minus, when you are multiplying a positive and a negative integer, it is minus 4 plus negative integer raised to an even power is positive, it is plus 4. You can cancel plus 4 and minus 4. You are left with 4 only. Then a squared minus b squared. A squared is 2 squared minus b squared is minus 2 whole square. 2 square is 4 minus, don't multiply these two again, minus negative integer raised to even power is positive, it is plus 4. You will get 0. Okay. Now, rules and formulae in mathematics are written in a concise and general form using algebraic expressions. For example, the area of a rectangle is length into breadth, it is LB, where L is the length and B is the breadth of the rectangle. So in general, the general nth term of a number pattern or a sequence is an expression in terms of n. So thus, nth term of the number pattern, that is 11, 21, 31, 41. So how do you represent this? This is 10n. 10n is if you give n equals 1, then this becomes 10 into 1 plus 1, which is 10 plus 1 is 11. When you give 10 equals 2, then it is 10 into 2 plus 1, 20 plus 1, which is 21, like this. So, okay. So, thus using algebra, we can reduce the length of the expression. Okay, we can express it in a short form. Now coming to the second chapter, that is exponents and parts. Very large numbers are difficult to read, understand, compare and operate upon. To make all these easier, we use exponents, converting many of the large numbers to in a shorter form. So you can define exponent as a shortened form of very large numbers or very small numbers. The following are exponential forms of some numbers. So it is here 10,000. It is written as 10 to the power 4 and read as 10 raised to 4. Okay, 343. It is 3 to the power 5. 3 to the power 5 is 243. Similarly, 127 is 2 to the power 7. 2 to the power 7 is 128. Here 10, 3 and 2 are the bases. 10, here it is 10. 10, 3 and 2 are said to be the bases, whereas this 5 and 7 are said to be the exponents, respective exponents. So we also say 10,000 is the fourth power of 10, 243 is the fifth power of 3, and similarly 128 is the seventh power of 2, like this. Numbers in exponential form obey certain laws, which are: for any non-zero integers a and b and whole numbers m, n, we have these laws. A to the power m into a to the power n is equal to a to the power m plus n. A to the power m divided by a to the power n is a to the power m minus n if m is greater than n, and it is equal to a to the power m divided by a to the power n is equal to 1 by a to the power n minus m if m is less than n. A to the power m out to the power n is a to the power m into n. A to the power m into a b to the power m is equal to ab to the power m. A to the power m divided by b to the power n is a by b out to the power m. And anything raised to the power 0 is always 1. Negative integer, negative number, any negative integer raised to even power is plus 1, that is positive, and negative integer raised to an odd power is always negative. Then coming to simple equations. An equation is a condition on a variable such that two expressions in the variable should have equal value. Equal value. Suppose we represent equations like this: x plus y is equal to 2, or even x plus 2 is equal to 5. All these are equations. Okay. So it is a condition on a variable. That means for particular values of x and y, or the variables, LHS will be equal to the RHS. Okay. The value of the variable for which the equation is satisfied is called a solution. For example, you consider this: x plus y is equal to x plus 2 is equal to 5. So in this, if you transpose 2 from LHS to RHS, then it becomes 5 minus 2, then it is 3. That means for this value of x, the equation is satisfied, isn't it? That is, in place of x I will put 3 and we have 2 is equal to 5. LHS becomes RHS. So this 3 is said to be the solution of the equation. Okay. Next, an equation remains the same if LHS and RHS are interchanged. That is, see, if we have x plus 2 is equal to 5. You can also write it as 5 is equal to x plus 2. We are not doing any change. We are just interchanging. The value remains the same. In case of the balanced equation, if we add same number to both the sides, then LHS becomes equal to RHS. Suppose we have, say, x plus 2 is equal to say 5. 5. If we add same number x plus 2, suppose you add same number say 3 to this to both the sides. So 5 plus 2, sorry, plus 3. We are adding the same number to both the sides. Does it make any difference? No, it will be the same because you are adding the same number to both the sides. Okay. I will just show you children how I will verify with the solution. Okay. We have got the value of uh, x as 3 here. X as 3. Just a minute. We have got the value of x as 3 here. Okay. Let us substitute here. It is just verification. Okay. Now x is 3 plus 2 plus 3 is equal to 5 plus 3. 3 plus 2 is 5. 5 plus 3 is 8. 5 plus 3 is 8. Okay. So thus if you add same number to both the sides, then the equation will be balanced only. Balanced equation. Subtract the same number from both the sides. Suppose you have say x plus 2, you have x plus 2 is equal to 5. If you do minus 2, if you subtract 2 from both the sides, then you will be left with these 2 will get cancelled. X is equal to 3. Isn't it? That is what we have got here. So because you have subtracted the same number from both the sides. Okay. Next, multiply both sides by the same number. Suppose you have say 3x is equal to 3x is equal to 5. If this is the equation, then you multiply both the sides by the same number, like 3 into 2, 5 into 2. So 3 2s are 6x is equal to 10. Then the value will not be changed. If you simplify this, again you will get 3x is equal to 5. Original equation you will get. So when you multiply both the sides by the same number, the value of the equation remains the same. Divide both sides by the same number, the balance remains undisturbed. That is, the value of LHS remains equal to the value of RHS. Suppose you have 2x is equal to 10. Now when you divide both the sides by the same number, say 2, then x is equal to 5. 2 will get cancelled. 2 1s are 2 5s are. So x is equal to 5. Okay. We will follow this while simplifying equations, children. Okay. Now, the above property gives a systematic method of solving an equation. We can carry out a series of identical mathematical operations on the two sides of the equation in such a way that on one side of the sides and one of the sides of the sides we get just a variable. The last step is the solution. For example, as I have already told, say 3x is equal to 27. So when we divide both the sides by the same number, say by 3, then 3 1s are 3 9s are. Then the last step is the solution of the equation. Therefore, from this you can say that x is equal to 9. Okay. Then transposing means moving to the other side. Transposition of a number has the same effect as adding the same number. So I have shown this. Yes, x plus 3 is equal to 8 is there. So you can add the additive inverse of this. Additive inverse of this number, or you can just transpose the constant from one side to the other one. We carry out the transposition of an expression the same way as the transposition of a number. Okay. Uh, See, the same can be solved as x plus 3 minus 3 is equal to 8 minus 3. I have added minus 3, or I have subtracted minus 3 from both the sides. Okay. So it is as good as, these two will get cancelled. You will be left with x is equal to 5. It is as good as transposing the term. Okay. You have learnt how to construct simple algebraic expressions corresponding to practical situations. Suppose the cost of if suppose x denotes pen and y denotes uh, book, then the cost of 5 books, suppose we have the verbal sum like this, the cost of 5 pens and 2 books is 100 rupees. Then we can construct algebraic expressions to the verbal problems. You have also learnt how using the technique of doing the same mathematical operation, for example adding the same number on both sides, we could build an equation starting from its solution. Further, you have also learnt that you could relate a given equation to some appropriate practical situation and build a practical word problem or puzzle from the equation. Suppose you have given this, then you can say that you can form a statement for this. The sum of 5 times the pen and sum you have to know. The sum of 5 times the pen and twice the book is 100 rupees. Then find the cost of say each pen or book like this. Okay, I think that's all. In the next class, I am going to start 8th standard syllabus. Thank you children. You need to write all these things in your classwork. You need to keep 100 pages notebook for algebra. Thank you.